This is a demonstration of how to do an exploratory factor analysis. I shall be basing myself on this data set here, which is an artificial data set, but it's put together to give you some very clear answers to the analysis where ambiguity is in fact rather more common. And I'm going to be guided by this flowchart that I've produced here for your benefit. So I'm going to go through the various steps and show you how they're done. The pre-check: is sample size adequate, and have you got enough variables? Well, in this case I would say that first thing to note is that the sample size is not adequate. This is purely for demonstration purposes only. You'll see that there are only 30 participants providing data here. This would normally be far too small to give you a valid factor analysis. The general rule of thumb is that you should have at least 100 cases, so I shall just say that straight away. When you're thinking about samples, factor analysis is not something you can do on small samples. Okay, what's the next check? Have you at least 3 variables per likely factor? Well, and not too many. Well, how many we got? We've got 9 variables here. As for how many likely factors there are, of course this depends on whether you have a hypothesis about how many there are likely to be, and in this case I don't, so I'm just going to kind of ignore that part of the box. Right, now in SPSS we go to Analyze, and I've said to data reduction. Well, in the very latest version of SPSS they call this dimension reduction. In previous versions it is data reduction, but it's all under the Analyze menu. In any case, it's pretty clear what to do. Then you go into the factor analysis and you place all the variables, hold down the shift key, click on the bottom one, and put the variables into the right hand box. Let's just go through these boxes. The first one to open up is descriptives, and here we need to click KMO and Bartlett's test sphericity. At this stage the only other thing I'm going to do is go into extraction. And I'm going to check the scree plot button, because that's a very useful piece of information. Well, the KMO measure of sampling adequacy, despite the small size of the sample, it's telling me that it's over 0.6, and therefore for the purpose of the analysis it is adequate. Bartlett's test sphericity is significant, and that's what we want. Lack of significance means there are probably no significant factors. In other words, the variables are essentially independent. The next thing I do is look at the scree plot. Well, here, basically because I made up the numbers, but you will seldom see anything quite as clear as this. But you see there's a very, very clear dip from the 3 points up here to the beginning of what you might call the scree down here, this kind of rubbish end of the variance spectrum. Now, we count the number of factors as being the number of, essentially, of dots before this huge, this very sharp angular elbow here. So there's a very clear 3-factor solution, and we use that. We go back to the analysis. So what I've done so far is I've clicked KMO's and Bartlett's test, and I've clicked the scree plot, and I've decided that there are 3 factors. So what do I do next? I go back to extraction, choose principal axis factoring, and insert the numbers that I've already got. So I will go back and basically do the whole thing again. The default setting, by the way, is principal components analysis. This is not what we want. This is fine for doing the scree plot, but it's not what we want for continuing the analysis. I'm going to do principal axis factoring. And the other thing we don't want is the default setting for this extract box. We don't want the decision based on eigenvalues greater than 1. That's known as Kaiser's criterion for the number of factors, and it's usually quite misleading. It's much better to go on the basis of the scree plot. So, where have we got to now? Well, in fact, I've pressed the button a little too early, because we should have done one other thing before proceeding. So I'll go back into the factor analysis, and I'll go into the rotation box. Well, what this suggests is that we can take one of two decisions here. If the factors are known to be orthogonal, and there'll be more about this in the lecture itself, we choose something called the varimax, which is this box here. The default setting is none. However, if we don't know or have strong reason to suspect this, we use something called the Promax rotation method. And that's what I'm going to do here, because I'm assuming we don't have any hypotheses. Just accept the default setting for kappa here, and we'll continue. Now, before we go further, we need to now carry out the analysis and look at the factor correlations. And we get these here from this factor correlation box, or matrix. None of the entries off the main diagonal are larger in absolute value than 0.2, or if you like, smaller than minus 0.2. So this means that in effect we should make the assumption that the factors are not correlated. We should use the most parsimonious hypothesis, and therefore we should go back to the rotation box again, and this time we put in varimax instead. And now we actually do go through the analysis properly. So we've got to this stage. Sorry, one more thing before we can actually easily interpret the results. That is to go to the options box here and click these two boxes. We want them sorted by size, and we also want the small correlations to be suppressed. And the number I'm going to put in is rather larger than the default. I'm going to put 0.4 in. And now at last we're getting an output which is going to be meaningful. And in fact, we look at the rotated factor matrix, and this shows us a very simple structure. We've gone down the varimax route, so we're at box 9 at this stage. And it says, examine the rotated factor matrix for evidence of simple structure. If by chance we had actually decided to go with the Promax output, I'll just show you what that means. Back here we would have something that rather different. We would have, in fact, two matrices to look at, and with an orthogonal method like Promax, we always look at the pattern matrix rather than the structure matrix. But in this case, we've decided to go with the varimax, and so we only have one. We just have one rotated factor matrix to look at, and this shows a very simple structure. We see that 3 of the variables load very highly on factor 1, which means that they correlate highly together. Another 3 load very highly onto factor 2, and the final ones load onto factor 3. And that is basically how you do a factor analysis.